Assalamu alaikum everyone. Welcome to PharmD with Anamta. If you are a PharmD student struggling with physical pharmacy, this lecture series will make the subject very easy for you. In today's lecture, we will cover these topics and I will explain them with some real life examples and some pharmaceutical examples so you can remember them easily for your exams. Let's start with the introduction that physical pharmacy is the branch of pharmaceutical sciences that studies the physical and chemical principles behind drug formulations. It helps pharmacists understand how drugs dissolve, that means solubility, how medicines remain stable, that means stability, how particles move in solutions, that is diffusion, and how medicines are absorbed in the body. Now let's discuss our first concept, which is density. Density tells us how much mass is present in a given volume of a substance. Let's take an example that we have two glasses. One contains water and the other contains sugar syrup, but both have the same volume, but the syrup feels heavier. This means syrup has higher density because it contains more mass in the same volume. In pharmacy, density is important for syrup, suspension, liquid drug formulations. Pharmacists must calculate density to ensure the accurate drug concentrations. Now let's discuss another important topic, that is viscosity. Viscosity means resistance of a liquid to flow. Think about water and honey. Water flows very easily while honey flows very slowly. This means honey has high viscosity and the water has low viscosity. In pharmacy, proper viscosity ensures the medicine is easy to pour, swallow, or apply. Now introduce important laws PharmD students must know. One of the important law is Fick's law of diffusion. Fick's law explains how drug molecules move across biological membranes. Drugs move from an area of high concentration to low concentration. This process is called diffusion. Now let's discuss a real life example, that is perfume in a room. If you spray a perfume in one corner of a room, the smell gradually spreads throughout the room. This happens because perfume molecules move from high concentration to low concentration. This process follows Fick's law of diffusion. Now let's discuss how it is related to pharmacy. Fick's law is extremely important in drug absorption. When you take a tablet, the drug molecules diffuse across the intestinal membrane into the bloodstream. The higher the concentration of the drug at the absorption site, the faster the diffusion in the blood. This process follows Fick's law. And if there is the slower the diffusion in the blood, then there will be the slow response of the drug. Let's discuss another important law, that is Stokes law. It explains how particles settle in suspension. Larger particles settle faster while smaller particles remain suspended for longer time. The real life example is muddy water. If you mix mud in water and leave it undisturbed for some time, then the larger particles settle down at the bottom. The large particles take more time to settle down and redisperse, and the smaller particles take less time to redisperse and settle down. It means the sedimentation rate is directly proportional to the size of particles. And this setting is happens due to sedimentation, which follows Stokes law. In pharmacy related example, when a suspension bottle is left for some time, particles settle at the bottom, and when we shake it, they redisperse. That's why medicine bottles say shake well before use. Another important law in physical pharmacy is Raoult's law. It explains how solutes affect the vapor pressure of a solvent. Raoult's law explains that the solute decreases the vapor pressure of the solvent. This principle is important in understanding solutions and drug stability. Now discuss the most basic real life example, the sugar in water. Imagine you have pure water in a beaker, and when water molecule escapes so easily in the air. But when we dissolve sugar in it, the sugar molecules occupy space at the surface. So the water molecules cannot escape that easily. So the result is vapor pressure decreases. These behaviors follow Raoult's law. Pharmaceutical related example is when glycerine or propylene glycol is added to pharmaceutical solutions, the vapor pressure of the solute decreases, evaporation reduces, medicine become more stable. Now it's time to practice. I've added some MCQs on the screen. Try to solve them and comment your answers below. In the next lecture, I will discuss the correct answers and mention the names of students who answered correctly. If this lecture helped you to understand physical pharmacy easily, make sure to like the video and share it with your PharmD friends. In next video, we will discuss some more important exam topics, so don't forget to subscribe to PharmD with Anamta.